Welcome to the HVAC-OLOGY experience, where we talk about all things HVAC industry, topics that are so hot, they are cool.
Welcome to episode 2 of season 2. Hello, Kelly Patterson.
Hello, Ryan Hudson. How are you today?
I'm doing great. Thank you. How are you?
I am fabulous. Thank you.
Excellent. Kelly, I got a question for you.
Mm-hmm.
Do you have a theme song that has played in your head throughout your life?
Yes.
You want me to tell you mine first? You want to tell me your first?
I want you to tell me yours first.
Sanford and Sons. Yeah, Sanford and
So
Sons.
why?
I don't know.
Is that your personal theme song, or is that your
No, that's
just
not
the theme song that?
That's not my walkout music, like if I was about to go like in WrestleMania or something. It's actually
Right.
like my beatboxing down the street. I'll kind of have that one in my head every now and then. It's on my regular playlist.
Interesting.
How about yours?
So, mine is actually a commercial, a McDonald's commercial from when I was a little kid, and they start out with "Nipper Sinkers, we're going to lunch," and then it just plays in my head. "We are Nipper Sinkers, we're in luck. If it rains all week, just pretend you're a duck."
Oh my!
It is in my head for my whole life.
It's got to be a
Man.
hell.
Do you think
Yeah.
do you think a lot of people out there have theme songs in their head?
I feel like they do.
This is my first time talking about this, and it's
We should
crazy.
ask everyone now.
It's a great icebreaker. Yeah, party. I'm going to take this to my next party. I love it.
Yeah, we're gonna
That's
ask
right.
David next.
That's
David,
right.
do you have it? Do you have a theme song that runs in
I
your
do,
head?
but I'm almost afraid to say what it is because nobody's going to know what I'm talking about.
Nobody
and
knew mine.
It's not exactly, correct for today's environment, but there used to be this show I would watch as a kid, little kid, and it was called Combat, and it was about the Army, about World War II, and I was always fascinated with history, and my dad was in the Army, so he would always make me watch this show, and I loved it as a kid. A lot of action and fighting and stuff, and it goes something like the beginning is da 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 da. It goes on, and it's like that little da 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 da. And every time I'm standing in line bored or I'm nervous or something, I'm like da 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 da. It's really weird, So don't hold it against me, but that's mine.
Huh.
Look at that. 3 for 3. We have we have theme songs in our heads. That's
Yeah.
crazy.
It is crazy.
Mine is the
and
weirdest
awesome.
of all. You guys are at least normal, but I guess I'm ready for action. That's what mine is kind of teeing me up for, right?
There you go.
That's right. Yeah.
Ready for battle.
So, Kelly, can you believe when I was Googling around and researching, not thinking anything of it, that I happened to notice that HVACOLOGY, just one season under its belt, was one of the must-listen to HVAC podcasts for 2024. Can you believe it?
You know what? I cannot believe it. But I also will say this, Ryan.
Yeah,
You
go
are
ahead.
one of the most incredible co-hosts out there in the podcasting world. So
I don't
I
think so.
figure that it's all you. You have rocketed us to one of the must-listen podcasts.
I mean, if there was fame in HVAC podcasts, I feel like we're achieving it.
I mean, right?
Hold on to your dreams.
That's
right.
right. That's right.
That's right.
And I'm assuming maybe the guests you bring in may help a little bit,
No, it's
I
all
don't know.
Ryan. It's all Ryan.
Yeah,
I'm gonna give
you're
Ryan
gonna
all the
drop after this one. Sorry. I'm gonna skyrocket downward.
No, we're gonna do great.
No.
Oh man, I tell you, Kelly, the big thing that I have been thinking about lately, because we're on the cusp of it, is one, getting to general artificial intelligence in 2025.
Oh my gosh, yes.
Could you imagine if that happens? Number two, if you can compound that with quantum computing. And then number three, all of these bots, this Optimus that Tesla is building and Boston Dynamics is building. My guess, Kelly, is that we are on the cusp of some crazy 5-ish years. Now, the thing that always throws me off whenever I'm making these predictions is a little thing called economics. But
Mm.
I think that at least from the general AI standpoint, we are going down some crazy rabbit holes. Do you
We
agree?
are 100%. And I know that companies are investing billions in generative AI. So it is going to change the landscape of everything. And I think you're right, in the next 5 years. And it's astounding what you can do now.
It is
It
crazy.
is.
I was thrilled when I got spell check and GPS on my phone, and now, jeepers, you don't even need to drive your own car, so or write your own letters. It's amazing.
Yeah,
Or when you get in the car and your phone knows where it is that you're going.
right.
Scary.
Like it recommends, like, oh, you go here a lot. Unfortunately, mine's happy hour a little bit too often. But it's very strange. Like if I get into the car at like 4:30, which is when we'll typically have like an off-site meeting, it says, "Are you going to Garage Tavern?" Well, yes, I am, because it's 4:30.
I did that just last night. I got in about midnight into the Austin airport, and I drove my car, and I got in and opened my map thing, and I
Home.
punched it to start putting stuff in it. My address came up.
Yeah.
Because that's
It
the
knows.
connection every time. That was weird, but kind of neat.
Mm-hmm.
A little scary
Magic.
too. A little scary.
Magic.
So now is the big moment where I introduce the voice that you've been listening to, David Schurk with Innovative Air. Welcome.
Thank you. Pleasure to be here. I'm thrilled. I really am.
Yes, yes. And today on the podcast, we're going to be talking about dehumidification and what Innovative Air has come up with. And it's very interesting, and I'm excited to get into it. But before we do, David, the question that I like to ask is, how in the world did you get from that beautiful May day of graduation, I'm guessing May-ish, to where you are at today? Now, just as your life flashes before your eyes in strange situations, we're hoping this is 5-ish minutes. Ready? Go.
Wow. So, it's a long time ago, 43 some years ago. And I don't know, sheer luck, I guess, to a certain extent. There's times when I didn't think this was such a lucky endeavor to be involved in. There are still days like that. But quite honestly, my dad was involved in the business. He was vice president of a small heating, air conditioning, and plumbing wholesale company in Cedar Rapids, Iowa, where I was raised. And I would, as a kid, go down there and hang around and help them do inventory. And even through college, I would go and earn a few bucks in the summertime working there, loading trucks and stuff like that. And it just kind of grew on me. They had engineers, and I would watch the engineers doing their manual calculations for heat loss, heat gain, and duct sizing. And I'm like, that's pretty cool stuff. And so when I came out of engineering school, I just gravitated towards the industry. My dad had some contacts at Carrier Corporation, and I ended up going to work for Carrier Corporation in Des Moines, Iowa as a commercial sales engineer, and the rest is history, so to speak.
Wow.
So I just right place at the right time. I don't know that anybody, maybe they do. And I did. I don't know if anybody comes out of college with a focus on exactly what it is they want to do. And I thought I'd give it a try and see how it worked because it looked cool. I loved watching the guys do their calcs, and I thought I liked that kind of stuff. And then I realized I like sales even more because, you make a little more money doing that. That doesn't hurt. And I got to do it all. It's real technical. What I do is very technical, very engineering focused, solution focused. I love solving complex problems. And when you get into dehumidification and environmental control, every situation is a complex problem that needs a solution. So I've loved it.
Mm-hmm.
That's it.
And I mean, the opportunity to sell thermodynamics and the intricacies of that, and what you don't realize is how diverse our industry is. To your point, there was something you honed in on that you really liked and was interested in, and it was more on the engineering side of things, but there's also this mechanical side of things. There's how to leverage that product. It's amazing to me. We were talking before we started this show about the AHRI Expo, and we got one coming up here soon down in Florida. But just to see when you walk into this building, you always have this very narrow view of what it is that you're doing in your little world, your little bubble. But when you go to something like that expo, seeing all the different products, things you never even thought about before, it's just vast and very interesting. I agree with you.
Yeah, it's crazy. ASHRAE, which is, the host of the AHR, they have, I don't know, 50 to 60,000 worldwide members, right?
Mm-hmm.
And the AHR usually brings about 20,000 of those people in at
Mhm.
one location. But of the 20 or 50,000, there's, 6 degrees of Kevin Bacon. There's just hundreds of thousands of people that touch them. So it is a phenomenal, industry when you step back and look at it that way. I agree with you.
Yeah. Yeah, I agree. I mean, and then like the Kelly Pattersons of the world, we can't exist without the Kelly Pattersons of the world. Or at least
Right.
nobody would know about us.
Nobody would know. Yeah.
No.
Mm-mm. So, David, so with dehumidification, there's this traditional thought of being able to take a body of air and cool it. And when you bring down that temperature, you are able to wring out the grains of moisture in the air. And then the next thought is, well, I can't introduce this very cold air into creature comfort areas where people are habitating. And so then I have to reheat it. Well, the problem with that is that, well, ASHRAE doesn't really love that very much. One, because of the energy sucking that it is. And it's just a very, very inefficient way to provide dehumidification. And with dehumidification, you need it for a lot of different reasons. It's not just creature comfort, kind of looking in on innovative air. I think you guys have done a great job in the industrial sector to be able to provide solutions as well with that. I guess kind of talk me through how you go from that traditional cooling and heating for dehumidification to how did innovative air kind of rethink that to where we use the desiccant will and use the paper sheets that are impregnated with silica gel. Kind of walk me through how you guys rethought that traditional dehumidification.
I will. Yeah. And man, what a segue. That was just very well put. I'm writing this down. Everything you said, it was beautiful. And I'd like to say that we rethought things, and we have to an extent. But solid desiccant dehumidification has been around for 100 years. I got a 1936 ASHRAE guide that I got as a gift, and not that I was alive then, but I got it as a gift, and I was looking through it, and there's desiccant dehumidification, solid desiccant dehumidifications talked about in that guide, and there's information there that I use all the time, believe it or not, from that far back, and it goes back even further than that. What we've done is just over the last 40 years as a company, we have better developed the delivery of that technology to the marketplace through reps like yourselves, selling to your customers and dealing through engineers. And we've tried to broaden the array of applications that solid desiccant dehumidification has been up till now typically segmented to. And let me start with this real quick. You talked about a cold coil bringing the moisture out of the air, and that is a traditional system, and that's the way that dehumidification has traditionally been done in a lot of commercial and light industrial applications. You take a coil, you feed it with refrigerant or chilled water, you chill the surface of that coil to a certain temperature, you bring the warm, humid air into the coil, it hits the surfaces, it drops in temperature, it hits saturation, things condense, you wring the moisture out of the air, it goes into a drain pan through a drain line, you get rid of it outside, and leaving that coil then is air that's been cooled and dehumidified. The problem with that, when you get beyond traditional environmental applications, let's just throw a number out there, 72 degrees Fahrenheit at 50% relative humidity, is that you have to keep making that coil colder and colder and colder when you want to get lower relative humidities to wring more moisture out of it, right? And to your point, two things happen. You overcool the air to the point where you have to heat it back up, because if you were to distribute, let's just throw a number out there, 40-degree air to a space that needs to be deeply dehumidified, you would obviously get enough moisture out of the air, but you chill them out. They'd be, they have to wear coats. This is a scenario in hospital operating rooms all the time. So you have to heat that air back up to a comfortable temperature. It is energy inefficient. It is unsustainable from, today's perspective, but it's a part of the process. It's a necessary evil. Desiccants can help eliminate that done right. Okay, we can reduce or eliminate reheat completely in a lot of applications. Hospital operating rooms, one that I do all the time. But beyond that, when you get that coil surface to a temperature where it begins to frost or freeze at around 32 degrees Fahrenheit, you create a block of ice and air can't move through it. And traditional systems are done there. And you'd be amazed at the number of applications that require air that would, in theory, need to be cooled below 32 degrees Fahrenheit to create the environment necessary in the space. I'll give you one example, lithium battery manufacturing. You guys do that, right? We need to deliver air at a negative 80 degree dew point temperature, all right? Because we have to maintain lithium battery manufacturing plants at negative 40 degrees Fahrenheit dew point. That's the equivalent of the amount of moisture in negative 40 degree Fahrenheit air. You could not do that with a traditional system. It would have been a block of ice a long ways up the sensible temperature scale. So with desiccants, we can deliver those extremely low dew point temperatures. You talked about grains of moisture in the air, right? There's 7,000 grains per pound of water. Okay, we can deliver grains of air to the space at 0.001 grains per pound. That's 0.0017 thousandths of a pound of moisture in a pound of dry air. We can maintain relative humidities less than 1% in the space if needed. So that's just an example of where and how desiccants fit. And the beauty of it is, since we can take a very small quantity of air and just dry the living heck out of it, we can step up and fix a lot of traditional systems that are existing that are ailing or failing. We just decouple. We we deeply dry a small quantity of air and shove it back into the traditional system and make it more of a dehumidifier. So there's lots of times we'll have a unit that's there. It just isn't quite functioning from a standpoint of being able to maintain the relative humidity they want in the space. Maybe it's old. Maybe it hasn't been maintained. Maybe it never was designed right from the start. Maybe they've repurposed the space. They wanted 50% relative humidity. Now they need 40 and you can't get there. I just take a little bit of air and dry the heck out of it and shove it back in and make it work. And you guys are doing that all the time in applications, fixing things. So to make what should have been a short response really long like I did, what we're doing is just reshaping the thought process of applying desiccants to make it more mainstream with companies like yours that are used to dealing in those more mainstream, traditional commercial vertical market applications. Sorry I went so long. You can edit that if you need to.
So exciting.
No, we will keep it all.
Yeah,
so,
I love all of it.
So, David, you bring up a good point that if you take out, whenever an engineer or somebody's doing a design build solution or you're doing something from the ground up, there's a lot of things you have to put into play whenever you're designing a piece of equipment. And by having innovative air as a part of the solution, what you're doing is you're taking out one element, the need to dehumidify. And so really it allows the unit to be significantly different, because now you might have had to oversize that unit for some reason, and you can actually put the right size unit based off of the ability to dehumidify the air appropriately.
Absolutely right. And there's a lot of times I'll apply what I call a hybrid system, not only to fix jobs, existing jobs that aren't quite working right or aren't working right at all, but new jobs as well. Now, a desiccant unit's a little bit more pricey than a traditional unit. So if there's a large airflow circulation quantity that's required in the space, again, what I try to do is just in one way, shape, or form, break off the dehumidification load, handle it with as small a unit as I possibly can, because again, I can take a small quantity of air and dry the living, negative 80 degree dew point if I need to, and shove it back into that larger system, whether it's a existing system or a new system. And it makes it more cost effective because your piece of equipment here doing a majority of, air circulation, sensible heating, sensible cooling, filtration, humidification is much more cost effective from a first cost standpoint than my unit built into a gigantic unit and made to handle the entire process. So we're able to cost effectively do desiccant jobs, where in the past I would always hear desiccants are just too expensive. Well, they are, but if you look at it with a mindset of providing a solution that includes price, cost, because that's important, it's not that expensive, and many times it's much less than doing it a more traditional way, right? We can achieve better conditions than we could have done the traditional way. And I'll tell you, done right, a desiccant dehumidification system can be 20 to 30% more efficient and sustainable than a traditional system. So yeah, we got a great value proposition. We really do. We just got to get the word out. So that's why I'm thrilled to be here. I'm thrilled to be working with your company.
Well, and you mentioned first costs, right? But it sounds to me like you're also saving on life cycle costs, right? If the energy efficiency is better overall, you're saving money in the long run.
Yeah, I've had systems pay back from an energy expenditure standpoint within months. Now those are, teed up jobs for success, right. but it happens, and it's not unusual for it to pay back well within a year, right? And from a standpoint of maintainability, I've got this wheel that's dry, so it's not like a cooling coil that's getting wet and growing mold and mildew, and you got to come in and clean it. My desiccant wheel is always dry. If it does get dirty, you can blow it out with compressed air. You can take it out and wash it with soap and water. The key is keeping the filters, maintained and clean. If you do that, man, this system, it's a wheel that turns, it's a heater that fires, it's fans that move air. How much simpler does it get than that? I always call it thermodynamically eloquent. But, once a maintenance person gets their head wrapped around it, they go, I love this.
Yeah, you said something in there, David, about how a lot of times people think, oh, I can't afford the desiccant wheel because I'm thinking 1-to-1 CFM is required with providing a solution. But to your point, you can actually take a much smaller body of air and, as you say, dry it as dry as possible and be able to introduce it to the main body of air. And in doing so, you actually are dropping the humidity throughout the entire body of air.
Yeah, exactly. I can do it at a fraction of the airflow that a traditional system can, and a small fraction. And, that just means my unit is smaller and smaller and smaller. And we all know in this industry, it's dollars per CFM. And if I can keep the CFM as small as possible, yes, it's a little bit more pricey system, CFM to CFM, but I'm here instead of here, and you're here at a smaller dollar per CFM value. When you add the two together, man, it's a great solution. It covers all the bases, energy, sustainability, maintainability, first cost, and actually doing what needs to be done in the space to achieve the environment that they need, and that's always a struggle.
So maybe to help our audience, for the folks that are in the service part of our industry, kind of walk me through what's it look like to maintain an innovative air product. Is this something that we need to be touching every year? And I'll set it up a little bit. I want to talk in a few minutes the difference between innovative air's product and a traditional ERV. But before we go there, a lot of times when I'm walking through a building, a mechanical room, the product that is just not running, nobody touches it, looks at it anymore, is the ERV. And it's because they've allowed it to get to the point of failure. To your point, they didn't do the proper maintenance. And then so it fails, and then it's just, it no longer operates.
Yeah.
So with your product, what is needed to be able to clean out the wheel, and what kind of maintenance is needed?
Boy, that's a great question. So first of all, I'm a true believer that if an individual that's in charge of maintaining something or operating something or whatever the case might be, if they don't understand what it is and it looks weird, it's not going to get maintained. It's going to get shut off. I see it all the time. So I'm a firm believer that we as a team need to make sure we educate, everyone involved in the buying process, right? I want everybody on board. I want everybody to get it. I want them to understand the value of keeping this product running because it is phenomenal when done right. Okay. But beyond that, two things I want to mention. Number one, this is not an ERV. It is, and it doesn't do what ERVs does. It just looks like it because we got a wheel between two airstreams that oppose one another.
Right.
That's it. An ERV is transferring energy. It's typically the wheels rotating at 20 to 40 revolutions per minute. It's really cranking away. It's usually very narrow, and quite honestly, the matrix or the fluted material that holds just a little sprinkling of desiccant is usually pretty chintzy. Okay, I'm so sorry, but I've sold a lot of them. But they work when maintained. Don't get me wrong, and they're efficient and they do what they're supposed to do. Our wheel is an industrial product, right? It's about 12 to 16 inches deep. It is a fiberglass substrate that if you hit it with your hand, you would break your hand. You're not going to damage that wheel. It rotates at 8 revolutions per hour, so it's very slow, and we drive it with a chain. There's really no torque or wear or tear on that wheel, but we drive it with a chain because when you use belts, belts slip, belts break. Owners hate belts, and then they go, I hate a wheel. You know, if you can keep the wheel running and you can keep the filters clean and you can keep the dirt out of the wheel, regardless of whether it's a, I got to close this, sorry, something popped up on my screen, it's bugging me. There, sorry. If you can keep it doing what it's supposed to do and keep it maintained, it's going to work great. That holds true of everything, including a wet cooling coil further downstream. It's always full of mold and mildew and never producing the thermodynamic output that it should, and possibly aerosolizing mold into the space and infecting and killing people in hospital environments. It happens all the time. But the point is, you know, that wheel is dry. So if my wheel does need maintenance, you can do a couple of different things. Please keep the filters clean, you know, and change them, right? But beyond that, inspect it. If you see a degradation in output, look at the wheel, maybe blow it out with compressed air from one side to the other, you know, maybe take it out and wash it if you need to. Nobody ever does that, and I'm not expecting anyone to ever do it, but you could if you had to. And because it's opposing between two, or because it's positioned between two opposing airstreams, if something does plate out on this side of the wheel, when it rotates into that opposing airstream, it's going to get blown off. So it's somewhat self-cleaning. Keep it running. Understand what it does. Understand its value. You want to keep that unit running. ERVs as well. ERVs are going to take a little more work because they're a commercial product at best, sometimes a residential product. Mine's an industrial product driven by an industrial drive system that won't give you headaches. You will not have problems with it. And that's, I don't know if that answered the question, but that would be my advice. And it was a great question.
From a maintenance standpoint, yeah. So you have the ability to blow it out. You could if you wanted to, but you never really see it. You can take it out and you can wash it if you need to. And then motors are motors. If you need to replace it, you can replace it. And then just keep the filters clean.
And one thing about desiccant is, not to interrupt, I'm sorry, but I need to say this because I think it's important. We use a heater to regenerate the wheel, just like a chiller uses a compressor to create a thermodynamic gradient between indoors where you want to remove moisture and heat and outdoors where you want to pump it and get rid of it. We use a heater to create that thermodynamic gradient. So it's our compressor, right? And if I make the heater just a little bit bigger, right? I've got belts and suspenders. It's like having a compressor that's a little bit bigger. And if you need it, you use it. And if you don't have to. So if there is some degradation over time, over maybe 15 years, if I've got enough extra capacity, maybe 10% in that heater and its ability to produce warmer temperatures if necessary, then I've got a built-in belts and suspenders and basically a self-correcting system for inefficiencies that may occur over time. So in theory, it could be as simple as turning it on and just letting it run, right? And let it adjust as it needs to over time to make up for any deficiencies in maybe maintenance, right?
Right.
It happens.
So maybe to the listener who doesn't really know the difference between an ERV or ERU, you hear both acronyms. So ERV is Energy Recovery Ventilation or Energy Recovery Unit. And what it does is there's no mechanical cooling or heating that's going on inside of this unit. So the idea is that you're taking bathroom air, you're taking air that's conditioned in the space that normally would be exhausted out and wasted, and instead what it's doing is going through a ERV, and in there is a wheel that captures the heat energy or the cool of it, and you're bringing in outside air that's for a building or some sort. And normally, from an ASHRAE standpoint, I think it's 7.5 CFM. It's intermittent occupant, or 15 CFM per person that you need for people to breathe, getting fresh outside air. And so if you take that outside air and you use that energy wheel, you can lower it or increase it by some amount that allows you to downsize your unit. Hopefully I haven't gotten too complicated. And then
that's
the
a great
difference,
description.
yeah. And then with the desiccant wheel, what you're doing is you are mechanically heating one portion of the air to release those grains of moisture out to some other location, typically outside. And then 3/4 of that wheel, of that desiccant wheel, is taking the humid air and dehumidifying it. So completely different logics of why you're doing what you're doing. And so for those people who have seen an ERV and think that it's a desiccant wheel, it's actually significantly two different products with two totally different intents.
We will many times see ERVs upstream of our wheel, right? An ERV, to your point, is simply taking energy from an exhaust air stream and transferring over to a supply air stream and just trying to reuse it, recoup it, more efficient, more sustainable. It is not a dehumidifier. An ERV is not a dehumidifier. I'll just say it one more time. An ERV is not a dehumidifier. It's not 100% efficient. You cannot drop the dew point temperature of the air below the dew point temperature in the space to absorb moisture. You then need to cool it, dehumidify it, in addition to just transferring energy and trying to save money. What my unit then does is drop the dew point temperature. It is a dehumidifier. So in combination, it's wonderful. It's a more efficient system, but I don't need it to dehumidify the air. But an ERV definitely needs a dehumidification device if it's going to work properly. And that's a huge differentiator as well. You can walk up to a energy recovery unit, open the door. It's going to be thin. It's going to be rotating like crazy and probably squeaking. And it's probably going to be driven by a belt. You're going to open my door. You're going to see a 12 to 16 inch aluminum encased fiberglass substrate wheel rotating by a chain, a commercial industrial chain drive assembly at about 8 revolutions per hour. It barely moves. We need a lot of dwell time, a deep wheel and slow rotation to be able to dehumidify the air. Recovering energy is pretty easy. Sprinkle a little bit of desiccant in the ERV wheel and it does its thing. I've got a wheel that's just 80% of its mass is silica gel. It's heavily impregnated with silica gel because it's very difficult to remove moisture molecularly and hold that moisture, vast quantities of moisture, to dehumidify the air. That's what I do. That's what we do.
So earlier you were talking about hospitals and how Innovative Air has really found a niche in the hospital sector. And the reason why, for those of you listening, is because when you are working on the human eye or when you are cracking open a body, it is very important that you maintain a very specific humidity in that room where an operation is occurring. And so for as much as you might need humidity, a humidifier in the air, you also might be in a situation where you need to make sure that you dehumidify the air. And that's where Innovative Air comes into play.
Yep. You said it beautifully. All hospitals, I shouldn't say all, but most hospitals, if they have a group of surgery suites, they'll be kind of maintained under the watchful eye of ASHRAE Standard 170 that has guidance with regards to conditions that you need to maintain in the OR. ASHRAE Standard 170 says you need to maintain the OR between 30 and 60% relative humidity. That's about all they say. And the temperature range they give, I think, is 68 to 72. So it's warm. And then the range of relative humidity, throw a dart and see what you can hit and see if it works. And the problem is that when we get into orthos, for example, orthopedic suites, right? You've got doctors that are very heavily garbed. They're wearing 2 or 3 layers of gowning. They're wearing space helmets. They've got on gloves. They've got on boots. They're operating under high intensity lighting. They're using hammers and chisels and saws, and not to get too graphic, but they're rolling people around and cutting them apart and gluing them back together and rolling them around. And they very quickly begin to, they don't sweat. Surgeons don't sweat. They perspire, and they begin to perspire underneath all that clothing. So they think they're hot, and they are. They're entering into heat stress. So they always want it really cold in their OR. They love it at 60 degrees Fahrenheit. That's cold enough. When you're doing jumping jacks or running a marathon, you need to have pretty cold air around you to help keep you thermally comfortable. But the problem is that the way we dehumidify hospitals and hospital operating rooms, the minute you drop the temperature, the relative humidity shoots up. It's just psychrometrics. Psychrometrics, baby. I always tell people, we haven't dehumidified the air far enough to be able to reduce its temperature and maintain a low relative humidity. Very simple. So you drop the temperature to 60 degrees Fahrenheit, the relative humidity shoots up to 75% or more. You are now out of compliance with ASHRAE standard 170. And what you've done is inhibit the surgeon's ability to maintain comfort. And the reason is simply this: 25% of the way that we as humans maintain our thermal comfort and health is through the evaporation of perspiration from our skin. Now, we're sitting here looking at each other, and I'm not perspiring heavily. It's pretty comfortable, but you see, I got a lot of exposed skin, right? I really do. And for every pound of sweat that evaporates from my skin, I remove about 1,000 BTUs of heat from my body, okay? If you cannot remove the perspiration from your skin, even if there's very little there, you cannot maintain your comfort. And you can imagine these doctors and surgeons that are perspiring profusely. They are really in a heat stress realm. And the problem with a high relative humidity is you can't pull the moisture off their skin through their clothing into the air to evaporate it and to keep them cool. So what you have to do is have a low temperature, which is required. We get that, but you also have to have a very low relative humidity, somewhere around 40%. In that space, to literally wick that moisture, that perspiration off their skin through multiple layers of clothing to absorb that 25% of the heat that we need to reject and keep surgeons physiologically safe and comfortable. And they're miserable. And, they make it cold, and you make it cold, and they're more miserable. And then the facilities people, surgeons complain, you can't keep them happy. Well, we're killing them, I mean, we can make them happy. You just got to make sure you have the right combination of temperature and relative humidity. Unfortunately, ASHRAE has yet to, and they won't, and I get it, they have yet to combine temperature and relative humidity, particularly in more critical environments like hospital operating rooms, to get a point where it's not only compliant, but it increases the productivity of the occupants in the environment. And let me tell you what, I want my surgeon as productive and comfortable as he or she can be. I always joke, and I don't mean it, but if my surgeon wants to smoke a cigarette and drink a beer while he or she is operating on me, if it makes him happy, do it. I'm knocked out. I just want them on point. And when they're perspiring and dealing with wet clothing and they're cold and wet, and they're actually their body temperature is increasing, they're not comfortable, they certainly aren't productive, and they certainly aren't focused on me, who they're working on. And I'm all for improving those environments. And that's what we do in hospitals all the time with desiccants, solid desiccants. You got to have them. It just can't be done with any other technology to get down to the points I'm talking about. That combination of low temperature they love and low relative humidity that no one understands, but is critically important in making that combination work.
Yeah, absolutely. I think maybe to change gears a little bit from going from creature comfort to more industrial cooling, kind of what are some general applications you're seeing in the industrial market for innovative air, to where there's a product maybe that they are producing? Like, where are you guys seeing a great fit for dehumidification with the desiccant wheel?
So I mentioned lithium battery manufacturing. You're trying to maintain negative 40-degree dew point temperatures, less than 1% relative humidity in the space. There's nothing on the face of the earth that will do that other than a solid desiccant. Solid desiccant. Not even liquids can do that. There are liquid desiccants out there, and they have their place, but not in those types of really low dew point temperature environments. So you got to have a solid desiccant. But as well, let's just take one example, a wastewater treatment plant. You've got this gallery of piping that's 20 feet underneath the ground. And that piping, regardless of what you do, there's always something dripping and wet, and it's a mess inside those environments. And it's a slip hazard, and it's a mold growth hazard and stuff like that. What you have to do is provide air to the space that is at a lower dew point temperature than the temperature of the apparatus in the space that's condensing moisture. So we'll provide very low dew point temperature air to the space to absorb the moisture so that there is no dripping and there are no wet surfaces and all that stuff stays, productive. You don't want people slipping, you don't want mold, and as well, water and piping has a tendency to rust it after a while. So even underneath the insulation that can happen. So that's one example, but we do semiconductor manufacturing. You're making circuit boards, and any microscopic condensation of moisture on those surfaces can ruin them. And just like that, you can lose $1 million batch of circuit boards in a heartbeat. So we maintain those conditions so that there's no condensation, microscopic, you couldn't even see it, microscopic combination on those types of surfaces. We do pharmaceuticals. You can imagine trying to dry gel caps or trying to keep powders dry so you can shove them in the gel cap. Requires desiccant dehumidification. Archival storage for museums. I just did one with you guys not too long ago. Works great. 40% RH is what they want to keep these important historical documents from absorbing moisture and degrading, right? So we do that all the time. Military facilities where they're storing tanks and airplanes and stuff like that. You got to keep the metal from rusting, and you got to keep the sensitive electronics from condensing moisture on them. So when you go and you push the start button on your fighter jet, it fires up, and the missile guidance system is accurate, and all that and so many more require dry air to accomplish. And your options are accomplish it. Many times solid desiccants are a requirement, or don't accomplish it and put up with the negative ramifications, right?
Have you ever, so we talked earlier about how you're providing a body of air that is dehumidified, but on the flip side of that, there is hot, moist air that's being taken somewhere. Have you ever seen from an industrial setting to where actually that was a valuable commodity to have to be able to use somewhere else within their process? Or do you typically don't see anything with that hot, moist air other than getting rid of it?
We'll get into that sometimes. There'll be, perhaps live steam being emitted to the space. That's obviously a dehumidification load. Or sometimes it might be needed for humidification. Maybe it's useful at times of the year, but usually it's a problem. So, I'm a big advocate of a couple of things. Number one, don't let the moisture in, and any moisture that's there, get rid of it. And then if you need dehumidification, let's talk, right? So seal your buildings, keep the moisture out. If you've got a process, a steam kettle or something that's blowing steam off to the space, put a hood over it and get rid of it. And in that process, then if you could use it for heat recovery or heating hot water or heating makeup air in the wintertime, more power to you. But those are all negatives for me that I deal with all the time. And so I'm always like, let's look at the job. Let's assess it. I don't want to just throw a dehumidifier at it and cross my fingers and hope it'll work. Let's shore it up and make it tight. Let's make sure it's going to work and apply a properly sized system, as small as possible, to do the job once we've taken care of some of the other issues that are always there.
So you said as small as possible. So I know your products have the ability to go from anywhere from 75 CFM to 33,000 CFM. And if you're thinking of CFM as far as from tonnage standpoint, 400 tons, you're talking about the equivalent of like 80 tons of air worth, if you will. But so I think that's fantastic that you guys have such a wide range of application from that 75 CFM to 33,000 CFM. Kind of just curious as we kind of start to wind down, what's an interesting project that you guys faced, using maybe one of your larger pieces of equipment or one of your tiny pieces of equipment?
The larger ones are really cool and kind of, I guess, intuitive from a standpoint of, yeah, I get it. One thing we do a lot with is we have this little compact unit that you mentioned starting at 75 CFM, and it's available in increments of 75, 150, 300, and 600 CFM. And it's a little stainless steel box. It's got everything in it. It's got the fans, it's got the filters, it's got the heater, it's got the wheel. It's even driven by a chain. The wheel's sometimes that big, driven by a chain, it's super industrial product. We apply that to all kinds of unique scenarios, a lot of times to fix things, right? And people go, gosh, 600 CFM, how much moisture can you pull out of 600 CFM of air? And the answer is a lot, because I'm driving the dew point temperature down. Just an oversimplification. 600 CFM unit might remove about 25 pounds per hour. That would be the equivalent of about 25 of those little standalone dehumidifiers that you would put in a space and plug in and run a condensate line to. And can you imagine the hassle with trying to do that? It's not practical. My little tiny unit can solve those kind of problems. And from there, it's just, where can I apply it? And sometimes we'll side stream it in the return air and just pull a bunch of moisture out of the return before it goes back to an existing unit that was ailing and failing. And now we make it more of a dehumidifier. And I just, as I mentioned a couple times, I'm doing an archival storage facility with one of your offices right now through an engineer and an owner, historical documents, and that's exactly what we're doing. And we're shooting for 40% relative humidity in the space. And the traditional equipment that was there could never have accomplished that. A 600 CFM compact helped them get there. So it's sky's the limit.
Man, that is really impressive. I tell you, the wide breadth of usage for dehumidification, the innovative air has kind of thought through is very impressive. Now, to change gears a little bit, if you are listening and you happen to be on LinkedIn, there's a 6.25% chance that you are connected to Mr. David. David, you have 35,000 connections on LinkedIn. That's amazing, man.
I don't know what to say. I've been doing it. It's one of those things. I started doing it 10 years ago, kind of sort of when they first came out, right? And I was always one of those guys, when the fax machine came out, I thought it was cool. And then computers came out, and I thought, the computers are never going to catch on. Fax machines are cool. So I've never been an early adopter, of this kind of stuff. But I did early adopt LinkedIn because I just thought this is cool and fun, and it's going to be a great way to just kind of, chat with people. That's what I thought it was all about. And it's become much more. I do regular posts on LinkedIn. I try to do at least 3 times a week, typically Monday, Wednesday, and Friday. I have a couple of what I call series that I've come up with. One of them is Psychrometric Fridays. So every Friday I'll post something under the heading of Psychrometric Fridays, and I'll just maybe record something and or do some type of a psychrometric chart, graphic with an explanation of what's going on, and I'll put that out there, and it's received some pretty decent response, and I've got a pretty decent following from that. And usually every week when those posts hit, I'll see 20, 30, 40 requests for connections coming back to me, those that I hadn't had in the past. Now I'm hitting my limit on connections, so I have to be real careful who I connect to, but they'll follow me typically as well, and I don't necessarily have to connect to have a follower. So I would say every year I add 3, 4, 5,000 followers on a somewhat consistent basis now. So it
no big deal.
6 degrees of Kevin Bacon, it just boom.
Very good. Kelly, what did you learn new in this conversation today?
The coolest thing, do you get it? The coolest thing?
Pun intended.
Yeah, no, pun definitely intended. That this product can reduce the relative humidity to less than 1% if needed without making the air freezing cold. I think that's really amazing.
I couldn't agree more. It really is. I'm still baffled sometimes. I get it. I know how it works, but I'm like, that's just amazing.
Yeah,
just amazing.
very cool.
I love
It
it.
is.
That's why I love doing this. It's just, I have a blast.
Well, Kelly, what should people do if they've enjoyed this podcast today?
Well, they should follow David Schurk. I mean,
Absolutely.
obviously.
Please.
But please follow, like, and share our HVACology podcast.
Yes, we would really appreciate that.
I'll do
We
it.
would.
Mm-hmm. Well, David, it was great talking with you today. Thank you for taking time out of your day to speak with Kelly and I, and I think we're better for it. And Kelly, I think that's it.
I think that's it. Bye-bye.
Thank you.
Very cool.
Took a rocket past Saturn. Things don't seem to matter much to me anymore. Got lost inside a daydream. Get sick of all schemes they play on their machines. I lost so many words as I got older. You would have thought I would have stored them in a manila folder. Accidentally wrote these words down. Thought all the best of me faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside? But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me? I drove an hour to see you. Things just seem to matter more to me anyway. Got lost in reality, no answers to cancer, we never got to talk. Lost so many friends as I got older. Wish I had the strength to hold you a little bit longer. Always meant to write these words down. Thought all the best of you faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me? Always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought